Good afternoon. I'm very happy to welcome you here. My name is Jacek Nowak and I work at the University of Silesia in Katowice. And I figured on behalf of our university and on behalf of Rava Inc. Municipality Business Incubator, I want to welcome you here. Today we are happy to bring you the Open Dual lecture. This event is organized within the project Transfer for Europe and is co-funded thanks to European Union. So the title of today's event, of today's lecture, is Medical Robots, an opportunity for the doctors and their patients. This very interesting and technology and medicine-driven topic will be presented by two special guests. One of them is Professor Zbigniew Nawrat, who is by the way, graduate of physics studies at our University of Silesia, but is also known for a founder of the Cardiac Foundation and creator of Robin Heart and cardiosurgery robot. And our second guest is Professor Robertas Damaszewicz from Vytautas Magnus University, who is an IT specialist and works at the Faculty of Applied Science at this university. So not to take more time, I will pass my microphone to the Professor Zbigniew Nawrat. Welcome.
Okay, nice to see you here. It's better to talk to someone. First, I will show you my laboratory. I'm from Zabrze. It is 20 kilometers from Katowice. Interesting town because 40 years ago, Professor Zbigniew Religa performed first successful heart transplantation in this town. That the team cooperating with him in this time and in future create many kind of devices, technology suitable for treatment the patients. You have seen on the you will see on this picture and this is next on the slide, but on this film now video, a few aspects of my work and my team. Professor Zbigniew Religa was founded this Foundation of Cardiac Surgery Development for preparing the Institute of Heart Prosthesis. He was the first director of this institute. When he was the Ministry of Health, I changed the position and was from vice to director of this institute, and currently also work with this team you have seen on this film. We work on the artificial organs, the artificial heart and ventricles device, using the several technology for preparing it, but for design, the simulation modeling, physical modeling. I don't know, maybe someone from you is engineer or like me, physics. Study that it is nice to use the knowledge to prepare something important for human. It is my adventure. That you have seen the ventricles device. This ventricles device work in clinic 30 years. That first time was used in '93, and I spent many days in hospital introducing this technology for having the patients. It is the new, currently under the animal experiments, but this ventricles device pneumatic was used for the patients, for instance, for 2 years support in clinics. That is work is very, very good. Next, my job was connected with the robots. I prepared the Robin Heart surgery robot. We started in 2000. In the first 2 years, we prepared the robot with 7 degrees of freedom, not like Da Vinci robot, and try to prepare the next model till now. Because we lack of investor, that it is currently only the research, the laboratory, but if someone will interested in such experience, that's if you will be next time in Poland, please come to Zabrze Foundation. I will show it, and it is also occasion for test it. Because of lack of money, of course, that made our job now corresponding to the robots is using artificial intelligence and changing the software, because this we not need money for this. But I hope that maybe something will change also. We prefer the animal experiments in Katowice and Silesian Medical University research 15 years ago. Using this model, this robot in this time was the biggest surgery robot in the world, because may work as a free person in the table. That on this main arm we have also a small robot with two tools and video system. That it is 4 tools for surgery and 1 for observation. That in this time was really the better as a size and proposition. For preparing the new valve, biological valve, new design, new ventricular device, we use the computer simulation, but also for planning the operation. The first technology of virtual technology in medicine was used in my laboratory 20 years ago. First visualization using the laser for this kind of application, also in my laboratory. And I'm going to organize the many conferences, also the oldest conference about medical robots. It will be in December, that if it will be in hybrid, that it is possible to contact with us. And if you are interested, please look for my media. That I will give the address for look about the presentation showing during this conference. It will be in December, Friday and Saturday, first week in December. We organized also the surgery workshop for students. My circle of interesting students, the number is 300. I have 300 students from medicine in my team. They write books. In 2 years, they write 13 books. It's really a good team. Thank you for this presentation. And next will be the short film. Proszę pokazać jeszcze ten krótki film z tym, because presentation is in PDF. And will be the story about artificial intelligence and usage, the control system, that it is would show how we can regulate something. That is typical. Okay, now I try to show you my presentation, and will be connected with. After this overture is try to symphony. The key to modern medicine increase of productivity and standardization. That we need the robots and artificial intelligence for this due to demographic traits, and also its COVID situation showed the pandemic that the robots is very important for reduction of employment requirements. Also, the robots is very interesting because the sending not only information but also the action. And the market of medical robots is growing. It's interesting for people, about 20%. And I hope that Robin Heart robot also will have the place for this application in the future. But let's start with medicine. Because medical service is a process, but for showing this process, we have the questions and answer too. There is a problem. Please imagine that from the different perspective, from the cosmos, from the village, from the Europe, from the town, from the home, you have someone. For example, such man. And there is something going wrong. It's disease. It is alone, you are alone in home, where you are. And there is a disease, we don't know what, connected with this situation in the person, that they grow the information, because we have the information now. Yes, we have the man, and something goes wrong, and it's the very important information for this man. That there is a need. When we have the information and needs, that we want to have any possibility to talk about, to transfer this information. That we must answer, we organize the service of medicine, how to this message sent to anyone. What's the method for communications? What kind of telephone? What is this situation? Please imagine what is the several answer for this question, not easy as you see before. And contractors, to whom? To whom this message? To Ministry of Health, corresponding to COVID situation that all was closed. To doctor, if it is the doctor, but to colleagues, to whom this information we transfer. And for instance, we have decision that who is going to lead this process? How? It's maybe automatic, or someone have to decision what we do the next for this man. Okay, that if we need the transport, what kind of transport we can use? It's not easy, because this, you must decide that if you organize medical service, that you might get any answer for this question. What will be the transport of the person if the person needs something in different place where you are? Next, what kind of tools we will use for help? As example, it is the good situation. The results of the contact with doctor is good results. We have the better situation. Of course, that we have the question, how much? How to reward of service provider? You was wrong, now we're better, okay? That's how much is for it? No, but if the situation is bad, that it is also the question how to punish a service provider if you are not satisfied after this contact and communication. Regulate or no? That is this film I will show you. How much is it? Of course, we will see that the different situation, different country will have different answer for this question. How much is it? Time, money, sick days, number of individuals, premature death, loss of opportunities in competition between people, companies, national economies. Now, of course, information about ethics, religion, law, customs, hopes, dreams, that the medical service must answer for all these questions, showing the system that it is offered for you in home if you have any problems. Let's focus on the hospital. When I see such singing near the road, that many of you maybe have imagined the patients building, but for me, it is the more important information about team, the set of specialists working in this hospital. If we have special specialists, then we have a special instrument for each. We have choreography because we have several people, specialists in different places. That it is like choreography, very important for the results, final results of this. Of course, if you have many specialists, many instruments, that the knowledge, education, it's very important to create the results important for the patients. If we have many devices for user, the ergonomy, how to use it, is very important for the effect, for the results. Strategy, tactics, plans, tasks, very, very important for the results of the patient's treat. We have many methods for showing how to use this design of plan tasks for the people. It was the hospital as a team of people, but it is also the question what is inside hospital. If you see for the same building from the other side, we have seen, of course, the first door. and the people who show you, okay, this is better or not, let's go home. That is very important, the first door open, and who will invite you and say welcome? Maybe robot. How to cover the distance, because the hospital is big, many rooms, equipments, people, specialists. Patients must be provided with the right medicine, materials, devices, right time. But also, we have to eat. Also, if you have to eat inside, but also the laundry. Not everything is one-off. Next, of course, the manage is of that in hospital we have many informations to transfer this information, to collect this information, to transfer to the good people who need this information and who will use it. And we have the electric, pneumatic, water, gas, heat, huge. That in hospital work about 1,000 people in such building like this. The people, engineers, technical, etc. for support, and few doctors and one director. That it is, and about a few hundred or thousand patients. Of course, we have the patients are examined. It is the diagnostic apparatus for this patient. Patients being rehabilitated after this. And also, if he spent a long time in hospital, they have problem with board, how to use as child, 2 months, 3 months, half year in the hospital, and the feel is very important for the result also for these patients. We have many kind of possibility for better visualize the process and how to use it for these patients, for information showing and data collection. We have also the architectural opportunities, but also the limitations. For instance, in this place we need the robots. Yes, 1 tons weight. This is okay. It's possible or no? We must change what we can change. For instance, such the environment. Of course, it is the service staff for control it, for usage it, the synergy of apparatus and people during the operation like this, and medical services is a process, as I showed you now. Where should these robots be? Everywhere. In the kitchen, in the first door open, in the surgery room, everywhere the robots we can use, and of course using this information and a combination of artificial intelligence and in our algorithms. Every pair of hands and brain time of medical worker freed by working robots, including AI, is a benefit for the patients. This means a high standard of service and lower risk operational certainty and lower total costs. The goal, where's the goal? If you connect this from your home experience, hand automatic washing, we are better human if you have such automatic washing in your home, because we have time for himself and family. Medical service is a process, so when should these robots be used? When? Always. Commonly, use the energy and intelligence of machines to save yours for the benefit of those in the need to solve really difficult problems. There will never be a shortage of challenge in future. The goal, for instance, such using the machines for calculation. Why is medical robots being made? Example, for surgery. Surgery is a special kind of activity. It is direct physical method performing on the human. The important is the plan and tactics for the results. And we show the patients and the doctors that we can see that very important is the information. Also, the better surgeon that have the 5 senses, not only 1, for the operations. Better if have 3D or not 2D for use during the surgery. Surgery is also teamwork. The surgeon needs tools to work. Different tools, different shape, different handle, different results during the operation if you used. Of course, the surgeon changed into special outfit during the operations. But for me, as a constructor of the robot, the most important is how it's used, how to move, how to decide, and how to move it. Because I try to prepare the robots like the human. Let's start from the doctor. Zbigniew Religa here. And first, that we work between this doctor and this patient, trying to prepare these devices and methods for helping it. First, my job was hard because you know that if transplantation you perform, that the method for pumping the blood is very important for support the patients waiting for heart transplantation. That is the first ventricular device designed by me. It's beautiful, like woman or a good car. This is the first patient supported by this ventricular assist device. It is the new centrifugal and axle-rotary blood pump constructed in this laboratory. Next, my job is connected with the robots. The first, we look how the surgeon work and what is the forces need for operations, ergonomy, and first model, next model of the robots that's possible to use for this is one of which we sold the license for this. The biggest robot on the world 15 years ago from MCC. During the and new, also we prepared the uni-tools that's possible to use on the end of the robots, but also in the hand. It was really good new innovations. It is the telemanipulator that covers the distance is one of the experiments performed. Knitted touch that we perform using special sensor for it, and you can see many kind of planning the operation and using this robot, and also the milestones of my job and my colleagues working here in the Foundation of Cardiac Surgery development. But robots change medicine. If you have seen for the robots using in hospital, my colleague Robertas will show you more. That I will quickly show you only on the example of the robots used in hospital for surgery, but also for pharmacy. That, please imagine that nurses who have 1,000 patients and prepare the pills for the morning, for the 8 o'clock for each. It's not a restaurant. That robots can do it. Robots in laboratory. Next robots for also for hair, but also for washing, helping, Neuralink, very interesting robots. But also for transport, from vaccine production through diagnostic to vaccination, the fight against COVID, you remember this. But also the nano and micro robot performing in many kinds of laboratory, but also for psychotherapy, for therapy, for these people, for control the streets, for transport using different automated vehicles and drones, and also trying the message. In Poland, we have also several kinds of robots, and currently we have the huge number, 40 hospitals using the Da Vinci robot or CMR robots, and this is the mode for usage in clinics, and we have many hospitals using it. But the robots was started in Silesia and Katowice, the first robot near this building in clinic in Katowice, Chojec. I work in this time in this Chojec. That for me it was also the part of my life. Next was in Wrocław. But you can see on this picture all the Polish robots, not only the Robin Heart, but also for rehabilitation and the very kind of applications. I'll quickly show that only for orientation what kind of robots we have find in many clinics. It is good business. and to help, for instance, in the special situation where we have the problem with the human resources, like in COVID. Currently, the trend is use artificial intelligence for support the robots. First was Corindus robot a few years ago. Only one rotate tract was FDA approval for this. I also try to use artificial intelligence for our robot also, and evolutionary trend toward progressive automation we have seen in different kind of application. When I started at the beginning of this century for Liga, the project of Robin Hart cardiac surgical robot, there was 1 million industrial robot in the world, almost 3 million today. This year, the number of employees in Poland has finally increased to over 40, but in Germany, 10 times more. In China, 1,000 robots per 10,000 employees in the fabrics, in the companies. At the time, there were several Da Vinci robots in the world, and the first operation in Paris, Leipzig. And today we have 8,000 robots and million operations per year more. Why? Because it pays off. It's profits. One would like to answer a button, where in Poland to this day robotic operations are not included in several services. Currently, we have seen the many robots named core robots corresponding with the humans in industry. That it create a new technology will be a very impossible, very simple transfer to medicine. You will see. The most important advantage is standardization. Because if you have any kind of surgery, such that the standardization, the distance between the doctor and the patient, the computer between, create possibility for standardization for preparing the better results of this operation. We treat the human body as a biological, physical, chemical, and biocybernetic IT system. You remember that it's not only muscles. Why, MISA-E? This minimal invasive surgery and artificial intelligence, that generally artificial intelligence was created for communications between machinery and human intelligence. It's beneficial for the patients. Can such possibilities? Yes. The less invasive the surgery, the less visual sensory information we have, the more the role of artificial intelligence increases. That you can see if you understand the process, that we can change this doctor from this doctor. Last calculations, that if you change that, it's possible to build a computer. If you know how to calculate, how to change one number for another number after results of mathematical process. This is the first picture of the technology, medical technology I have found, but currently we have seen the 5 revolution AI-driven industry without people, for people, and also in medicine we have the same. Why does AI help surgeons? AI can help to improve surgical outcomes by providing surgeons with real-time information and feedback, enhancing the surgical planning and decision-making, and reducing the risk of complications during the surgery. Why do robots need AI? Robots need AI to be able to operate autonomously, make decisions, and perform a complex task. Currently, the medical robots and artificial intelligence support medical service in the richest countries in the world. However, the real breakthrough will occur when medical robots begin to help those who cannot afford normal healthcare service, when a group of beneficiaries appears. In all the world, we have about 400 million operations. That you have, please imagine the surgery room in Africa, in village, etc., etc. If it is possible to transfer this technology to this place, that will be really benefit for it. And my one thesis is that thanks to such organization and AI, we can navigate our cars for free in any countries, whereas we use the telephone with computers. That it is example that technology it is possible to transfer to all the people without not big money if it's prepared. The key is AI. I have no doubt that without AI, robots will never overcome this barrier, the barrier of interest and business. AI is here to communicate with human intelligence, to free up human hands, and to enable humans to being human. After the success of remote transfer of data, currently we have possibility to transfer the action that the robots will use for it, and men are from Mars, maybe women are from Venus, but robots are from Earth. Let's do it better. Robots should be considered as elements of human future that will make it possible to raise the dreams of freedom, equals, and free management. Because we do really great things out of curiosity, but the real important things out of the need to help other people. And last my slides is connected more wider because as you remember the slavery, it is also the problem not only in the last hundreds years, but also now. But if we see that robots are the only solution to solve the problem of slavery, people will no longer profit from using free labor because it's possible doing by robots. That also, I think that it's also very interesting advantage of robotics and artificial intelligence that is create another kind of connection with the people. We not need the job of you and you because I have robots for using it. That will be also the future will be the better. After all, we know better forms of transport. Robots are an evolutionary consequence of the development of the tools from human control and actuated hand tools by machines, manipulator to independent executive devices, and innovation is the marriage of ideas and sales. I believe it's possible. You will definitely success. Please do robots. Thank you for possibility for presentation here for you. Zdążyłem w czasie.
So my proposition was to stay with questions after 2 lectures, but maybe there is time so we can raise the questions. So because I saw that there was one question already. So I will give you the mic because it's necessary to hear you.
Perfect. Thank you for your presentation. Regarding men are from Mars, humans are from Venus, and AIs or robots are from Earth. In your perspective, I know that as a person, I don't want to hear that medicine is standardized and that everyone is like, you can like standardize every physician because I'm like, okay, my doctor needs to take care of me individually. But regarding AI, right now we have the issue that AI is mainly focused and mainly trained by men on the male body. At least that is what I know of the part of the research right now. That it's mainly focusing on male individuals. So how can we then use that information in surgery on female bodies?
Maybe I not catch all your intention in the questions, but of course the first information is that we are not digital. Human is not digital. The success of AI is possible if we have the numbers, because we can use it. Also the picture, but picture transfer to numbers, etc. That the most important for help the people is changing all the information about us for the information, for the digital information, store this information, calculate this, look what was changed from Monday to Tuesday, etc., etc. That is the most important is changing the information for digitalization process, using the digitalization process. Of course, we need for this the sensors, the devices that prepare the picture of us using RTG, USG, etc., physical phenomena that can show something inside, because all the information important is not visible about us. For instance, my students' last startups organized for histopathology test, because you know that's many kind of glasses and pictures that transfer it for digit, and next try to help the doctors for preparing the more quick information and also storage the information in the shot in the place in the computer. The information digitalization in the one key. Next is a sensor. If we look for you, each one, the better human activity is connected with the sensors. If we have here ACE working, that we can something do and transfer this information for our knowledge and also changing the world. If you haven't it, that no. And all this information for change for digit is not very easy. That it is the neural link one of these the problem. The first artificial AI 40 years ago have no, I think 25 or 24 the eagle in human, and what is the vision possible to do using so small information from the inside. That if we all this information preparing and storage and create the knowledge possible to use for the algorithms, for computers, for the artificial intelligence, that will create the possibility for create the usage of artificial intelligence in each the process. If we prepare the, I guess one two chain. If you imagine the service medicine service of the chain, that first is the progress information, diagnosis, therapy, etc., that between all this chain, currently we haven't the connection. Artificial intelligence is the super in this place because they collected the data, and if you need it, give you it. That it is the artificial intelligence is between this chain very important, between diagnosis and therapy and rehabilitations, in-home patients control. That artificial intelligence as an observer and using this number for any kind of decision preparing is very important, because it gives us information that please go to the hospital, for instance, tomorrow, because something was changed. Currently, I don't know, but maybe that it is this future for artificial intelligence. I think it's very, very interesting, because these new methods for using artificial intelligence create possibility to preparing this knowledge only looking for the data. Any laws and scientists not important in this process. They all look, transfer data. Okay, I have something interesting in this picture, something interesting in this pressure measure in your steps. Is too long or no? Something's changed, and the looking for this change. It is the job for observer, AI observer of us. Okay? I give a chance, my colleague.
So we will have a short technical break.
very honored by this invitation, and it's a very good opportunity to discuss this important topic of medical robotics, which is very interesting both to me personally. First of all, a few words about myself. Currently, I am professor at Vytautas Magnus University in Lithuania. I am professor at Kaunas University of Technology, also in Lithuania, and also I am affiliated with Silesian University of Technology, not a long distance from here in Gliwice. I'm also editor-in-chief of Information Technology and Control journal, which publishes also some papers on robots. So you may be interesting to read the papers which have been published. My work with robots, my interests are more from the academic side. So I deliver some courses on robot programming for students. Also, I do research which is connected to medical image processing, to recognizing various types of diseases, also to the problem of health and assisted living. So to live better lives, not only the patients, the people who have some conditions, but also for healthy people to improve their everyday lives. The science of medicine evolved over a long time, and during this evolution, it has undergone several revolutions. So my colleague mentioned industrial revolutions. So medicine also had its own revolutions, and we may not go too deep into our past. If we go to the 19th century, we had something like discovery of a germs theory and the understanding of the benefits of sanitation, which allowed to improve the quality of life dramatically, and also led to some developments in preventive medicine. In the 20th century, we had a lot of very important milestones. What is most interesting personal to me is the various medical imaging technologies like X-rays, also magnetic resonance imaging, and also CT scans, which allow to look into the internal of the body without doing some invasive procedures. So you no longer need to cut the body. You can just look through the body and find some abnormalities which could be indicative of some kind of disease. So in the 23rd century, we have very fast developments in medical robotics. So the efforts are done to trying to achieve the precision, achieve the accuracy which is required to do various surgeries. Also, applications in various related areas, like in hospital management, to develop robots which could carry various things across the hospital. They could provide information, they could ensure teleoperation services, and many other related activities which allow to transit to personalized medicine. So you can tailor, with the help of artificial intelligence, the health services to each individual person, each individual patient. Okay, so what are medical robots? Do you know what are medical robots? How can you characterize them? What is the most important thing in medical robots? So first of all, we are developed to carry out some specific medical tasks or some specific medical procedures. So the aim is health sector, and these robots are autonomous or semi-autonomous machines. So we are basically something which is beyond the usual tool. So it's not just a complex tool, but it's a level above the tool, which allows the robots to do something without the need of an operator which directly controls all of the motions. So you can see several typical examples of robots, such as pharmacy automation robots. So if you have a very large hospital with thousands of patients, each patient every day must receive a specific dose of some medication. So it would be a very large task to have these medications prepared and delivered for every patient. But robots can automate this task. They can prepare medications for each patient, and then you can have the moving robots which could drive through the hospital and deliver each medication to each room with a specific patient. Also, you can have rehabilitation robots. So basically, if some people have some traumas, some disease which affect the movements. For example, they have after trauma they have broken bones, and they need to restore the function of the limbs, like hands or legs. You need to train this limb to restore this function. So rehabilitation robots help to train this limb to restore muscular power and to restore the capabilities of humans. Telemedicine robots are aimed to ensure the delivery of health services remotely over distance. So there is no need that the patient and the doctor is physically at the same room. They can be separated by long distance, and the telehealth infrastructure ensures that they can communicate to each other. The doctor can inspect the patient, can take some samples, for example, of blood, using robotic system, and then he can consult which medications, for example, could be taken. And surgical robots, which of course mentioned prominently by my colleague, to go into a human body to do some operations which previously only surgeons could do, but robots in some cases can do it with more accuracy and precision. So if you classify the robots according to various properties or various characteristics, so you can have different types of medical robots based on various levels of autonomy. Teleoperated robot is just a complex tool. So it always is controlled by human operator. The robot only extends the capabilities of a human operator. So, for example, it's some kind of a robotic hand controlled directly by the surgeon, which can make, for example, some cuts in the human body. The advantage is that human hand can have, for example, some tremors, which are unwanted. The controlled robotic hand will not have these tremors and can make very, very precise cuts. Semi-autonomous robots, they can do some simple pre-programmed actions, like, for example, drill a hole in the bowl, but they still require some human oversight or some human action at some stage of the operation. And fully autonomous robots, they should rely on algorithms, artificial intelligence, to do certain medical procedures fully automatically without the direct involvement of a human person. According to the interaction, we can have collaborative robots, or so-called cobots. The aim is to assist healthcare professionals in doing some medical procedures. So basically, they cooperate. The professional does its part of job, his part of job, or her part of job. Robot does its part of job, and they collaborate. Independent robot should be able to work without direct human interaction. And based on the application, you can have diagnostic robots to find the disease and therapeutic robots to do some therapy or to do some treatment. Some milestones in medical robotics, some famous robots which also have been mentioned in previous presentation. Basically, the robots evolved from less complex robots which did only very specific part of a surgery operation, like drilling a hole or doing the cut, and then surgeons overtake, to expand over more complex types of medical procedures, which require both experience and also require more complicated actions from the robot. And the complexity also grows. So basically, starting from some operations on the bone to the robot Puma 200, which was able to take biopsy from the brain, so drill through the bone, take some small part of brain material for analysis. Very complicated procedure, because if you take too much, it's bad. So very high level of precision is required, and in this case, the robot can replace the human surgeon. Of course, Da Vinci, very widely known system, which was first system approved for general laparoscopy. So laparoscopy is going through small hole in the abdomen, yes, and doing some work. I'm not a medical person, but you can imagine there's also a high level of complexity involved. So what is currently done now is the integration with artificial intelligence. So basically, the robots, through the sensors, can collect a very big amounts of data about the patient. So during operation, you can scan all the condition of the body. You can do imaging inside of the body, and based on this information, if it is processed in real time, the robots can take very informed decisions about what to do next. So they can guide, or they can advise the healthcare professionals, the surgeons, or they can do specific procedures based on this information. Some of the modern medical systems, and I can start the video, so it's explained better.
Most advanced platform for minimally invasive surgery available in the world today. The integration of high-resolution 3D vision, wristed instruments, and intuitive motion control enable the Da Vinci surgeon to transcend the limitations of conventional surgical technologies. 3 network components comprise the Da Vinci surgical system: an ergonomic surgeon's console, a patient-side cart with 4 interactive robotic arms, and a high-definition 3D vision system. Seated at the console, the Da Vinci surgeon views a remarkably clear 3D image of the surgical field. The system scales, filters, and translates the movements of the surgeon's hands on the master controllers to 4 interactive robotic arms on the patient cart. The precisely controlled micro-movements of the Da Vinci instruments are enabled by the computer processors of the system. These dedicated processors perform millions of safety checks over the course of a procedure for enhanced surgical precision and control. Da Vinci EndoWrist instruments are designed with a unique wristed architecture that provides 7 degrees of freedom for a range of motion greater than even the human wrist. This proprietary design enables surgical maneuvers impossible with conventional laparoscopic tools. The system requires that every surgical maneuver is under the direct control of the surgeon. Redundant safety checks prevent autonomous movement of the instruments or the robotic arms. The Da Vinci S surgical system moves surgery forward with a new level of technical capability that enables minimally invasive surgery in complex procedures as never before. Da Vinci provides a streamlined surgical experience that benefits the hospital, the surgeon, the OR team, and, most importantly, the patient.
So the most important things to mention, it has 3 arms. Not 2 as humans, but 3 arms. So it can do more complex procedures, more complex cuts than humans. Also, the capabilities are better than humans. So the ability to turn this wrist is better than in humans. And of course, the 3D high-resolution vision, which allows to see very clearly the entire field of the surgery. And another system called Robotics Renaissance is dedicated to spine surgery.
Require the advanced technology of Major Robotics Renaissance Guidance System, a system transforming spine surgery. Surgery of the spine requires planning and precision, and each patient's anatomy has unique challenges. Surgery with the Robotic Surgical Guidance System allows neurosurgeons to plan ahead before entering the operating room. Neurosurgeons use the advanced 3D planning software before surgery to create a unique surgical blueprint, which is specific to each patient's anatomy. During surgery, the neurosurgeon does the actual work, but the neurosurgeon's tools are guided, according to the surgical blueprint, to place the implant safely and with the highest level of accuracy in the exact pre-planned locations. In fact, robotics technology has been clinically validated to ensure 1.5 millimeter accuracy for increased patient safety compared to freehand spine surgery.
So, what is important for these spinal surgeries is to do planning, and this system allows to do 3-dimensional planning specifically on the person which is operated, because we are all different, we have different height, different complexion, and this system allows specifically to focus on the characteristics of the operated person.
The Da Vinci surgical system is the most advanced.
Okay, sorry. Another type of robots are dedicated for rehabilitation. So to allow the person which had his or her capabilities reduced due to some trauma or disease to regain its motoric functions.
Providing highly intensive physiological gait rehabilitation to severely impaired neurological patients is a huge challenge for health professionals today. This is where Hokoma's innovative solutions can help. The Lokomat is the world's leading robotic medical device that provides a highly repetitive physiological gait training, especially to severely impaired patients. The combination of adjustable orthosis, a patented dynamic bodyweight support system, and sensorimotor stimulation ensures the most physiological gait training on the market. Motivating real-time feedback results in active training participation by the patient and increased self-activation of residual functions. Therapists can continuously adapt training parameters to the patient's abilities at every stage of their recovery. The objective documentation of the patient's progress supports communication to the patient, medical experts, and health insurers. The safe training environment for the patient opens new possibilities to increase therapy intensity in efficient settings. Hokoma's Lokomat, the most trusted gait robot. getting your patients back on their feet.
So this type of robot is called exoskeleton because it's put on the human body to support the movement of its limbs, the movement of muscles, and this system allows to perform, to implement individual rehabilitation programs specifically adapted to the type of trauma, type of disease, and it also has some additional very interesting features like motivation program, because these things are usually painful, they are difficult to do. So you saw a screen which shows some motivating pictures and motivating this person to do these exercises so that his function improves. And another system is also exoskeleton type. Hand of Hope.
Hand of Hope is an EMG-driven robotic arm exoskeleton that helps patients to recover after a stroke. Hand of Hope is relatively easy and quick to set up by following simple instructions. Rehab Robotics and Hong Kong Polytechnic University work together to develop it. The effectiveness of this patented technology is proven by clinical trials and published research papers. Hand of Hope detects the patient's intentions to move the impaired hand. Voluntary EMG signals are commanded by the brain and detected by sensors. As an active and assistive device, it processes these signals and delivers them to the hand brace. In that way, the robotic arm understands that the patient wants to open or grasp the hand. Hand of Hope has passive and active training modes for hand opening and grasping. 5 different games with 4 difficulty levels help the patient make the rehabilitation process more interesting and fun with audio and visual stimulation. Thanks to forearm support, the therapist can use the Hand of Hope for the whole arm recovery on different stages of rehabilitation. Also, therapists can easily extract the report on patients' performances in PDF or Excel file. Hand of Hope is an innovative, active, and assistive robotic device which uses EMG signals and exoskeleton to help the patient's in-arm motor relearning after the brain injury or stroke. Learn more about Hand of Hope at rehab-robotics.com or order a trial now.
Okay, so it's also exoskeleton. And it is used after stroke. The link between brain and muscles is somehow inhibited. So you need to retrain to use the hand again. And this device helps to do it by recognizing the intent. Apparently, the EMG signals, so signals which come from the muscles, they can be analyzed by signal processing, by artificial intelligence, and you can recognize intent. For example, this person wants or tries to move the hand in the specific way. The device recognizes the intent, and then, using mechanical parts, moves the fingers, like grasping or clutching, in the way which corresponds to the intent. And in this way, the hand is retrained to listen to the brain and to move correctly.
Providing highly intensive.
Okay, so another type of medical robot systems I used in the telemedicine for remote consultations. So this specific system is so-called telepresence robot. So robot which is located remotely, and it can be used in hospitals for remote consultations or for routine rounds. So the doctor doesn't have to visit every room with a patient. He can work from his cabinet and speak to the patient, ask about his conditions, and also do some checking. Of course, the robot, which you can see here, is just a moving rack with some medical tools. The checking is still performed by the human assistant, so I'm not showing this video. But it can be integrated with other medical devices, and most importantly with the information system of the hospital to retrieve some patient data in real time. Okay, and also this robot, which is used to carry things around in the hospital.
Tug by Aethon is the market-leading autonomous mobile robot used to transport materials and supplies through the enterprise. Tug is built on an omnidirectional platform using a four-wheel independently driven Mechanim drivetrain. The Exchange platform will carry a wide variety of interchangeable cart and rack configurations based on the customer specifications and their supplied carts, and navigates autonomously without the need for additional infrastructure. It does not require magnetic or wire guides as do traditional AGV systems. Tug can make on-demand or pre-scheduled deliveries. Tugs are reliable. A command center in Pittsburgh watches over them 24/7, 365 to ensure uptime. Tug will automatically pick up and drop off carts at specified locations. This unique feature maximizes material flow. Tug autonomously navigates through the facility, detecting and avoiding obstacles as it travels to any number of predefined locations. It integrates to building systems through Wi-Fi, and this allows Tug to call and ride elevators, to open doors, or even move out of the way in the event of an emergency. The Tug can be signaled for delivery or pickup through a variety of interfaces, or interfacing to a manufacturing execution system such as SAP. Tug, the market-leading autonomous mobile robot from Aethon.
So you can see that this robot is capable to perform a lot of lower-level jobs in the hospital, which is currently done by humans. By hand, they take something in one place and bring to another place, like medication or some instruments, some documents, or even food. This robot can replace it, and it has capabilities to move around obstacles, even to use elevator if it is needed. Okay, so as you can see, designing robots, implementing robots requires rather sophisticated science to implement, and this of course depends on the specific application, specific tasks performed. To implement robots, it's not like you take some common stuff and you assemble the robot. Even materials need to be specific. So you need some advanced materials which should be biocompatible. So if they contact with the body, with some body fluids, for example, they do not cause allergy, for example, or do not introduce infections. Also, you need some precision mechanics to do very precise actions with the robots. Sensor technology is very important. because you need various type of sensors to collect the data from the human body. Also, control systems are needed to implement the operations of a robot. As you saw, this moving rack robot, it needs to do some relatively simple control to avoid obstacles, which is a very common problem in robotics. But if surgery robots are implemented, then you need to have very complex and very precise actions. Telecommunication technology, so that you can implement this telemedicine, so that data can be both received and sent in a safe way, so that it is not lost, it is not revealed, it should be encrypted, so that the privacy of the data is maintained. And of course, artificial intelligence to ensure the decision-making capabilities of the robots, so that the level of autonomy could be increased. So if you look at the materials which are used in advanced robotics, biocompatible materials such as various parts made from titanium, for example, which do not cause some inflammation of the tissues, do not cause the immune response. Some medical grade polymers also they are accepted by the body if you need to put something into a human body. Flexible electronics are important if you implement some prosthetics. For example, the artificial hand which replaces the lost limb, or in case of some rehabilitation devices which should mimic how human tissues work. So they are flexible, they can be squeezed, they can be stretched, but they still maintain the function of collecting data and transmitting this data to the servers. And also these materials, they should be light, they should maintain strength so that they can be used for a long time and without the burden to the patient. Sensor technology is very important because this technology allows real-time monitoring, very important. You know, in many critical cases, you need to have data now, you need to take decisions what to do with the patient, what procedures apply to save his life. So this collection of data, is processing of data without latency is very important. Also, some other kind of sensors are required, such as, for example, haptic feedback. Haptic means touch. So for surgeons, for example, they are using some artificial hand, for example, to do cuts, but they need this feedback. We need to feel how the body reacts to this cut, how the tissues react. So it's very important for the success of the operation. And of course, safety mechanisms to check if everything is going okay, if no harm is done. If you remember a video from Da Vinci, we said that the processors do millions of safety checks every second to make sure that nothing bad is done to the patient. And integration with imaging, with all these imaging modalities, which can be done during surgeries, and they can provide real-time information about the condition of the patient. The control and interfaces which are used to control robot systems are also very important. The purpose is to achieve that both humans and robots work together in synergy. So they collaborate, and they have the flexibility of movement, they have precision, and at the same time robots can do some hard tasks which usually requires some strength from the surgeons, such as, for example, cutting the bone or drilling the bone. Typical examples of control system, this joystick used in video games also can be used to control medical robots because it's very common interface. It's easy to understand, easy to use, and you can move with precision specific parts of the robots. Other types of interfaces are touch interfaces. So, for example, you have a touch screen, and you can go select the area of interest. You can receive information about this area of interest just by touching. So it, of course, is an improvement of this mechanical interface, but still, in hospitals, in surgery rooms, touching something with hands, it's not good. It's a bad idea because these surfaces, they collect dust. They collect microbes, so if you touch it, you bring it on your own hands. So better solution when using touch screens is to use gesture-based systems. So basically you have cameras, sensors, which film or record movements, interpret these movements, and by doing some gestures, you can assign specific operations to these gestures so that specific operations like show data about patient or do some pre-programmed procedures. And another option is voice commands. You can assign specific operations to the voice commands, and just by saying, the medical doctors can cause the computer to show some information about patient or to proceed to the next stage of the medical procedure. Telecommunication technology is important for achieving three main aims. First of all, breaking geographical barriers. You know that the best doctors or top doctors are concentrated in rich countries, in the large cities within rich countries, in the top hospitals within these big cities. So if someone is ill in the remote, distant area, rural area, or in some remote country, they have no chance to receive high-quality procedure unless you can do it remotely by telemedicine. So in this case, you can arrange, for example, video conference by this remote system and do some consultation or do some collaborative surgery with the local personnel, local staff. So local surgeon does operation, the expert, the medical star observes this operation and can advise on the course of this operation. Also, you can implement training sessions for local staff. What is important is to ensure secure data transmission protocols, because this is private data and nobody wants it to be shown somewhere on the internet, for example. Also, the low latency communication channels are important to ensure real-time operations. So there are no latency, no time lost. And also integration with various diagnostic tools which allow to receive feedback about the state of the patient. And artificial intelligence is important for decision making because the human body can generate very large amounts of data from various different kinds of sensors. And by performing data processing, you can analyze images, analyze other types of data, spot some anomalies or some outliers or patterns which may be indicative of diseases. So this capability exceeds the capabilities of a normal person, because in many cases it's very difficult to formulate specific rules which can characterize this kind of disease, but artificial intelligence trained on large data sets can spot these cases and identify them. Also, predictive analysis. So based on the current condition, based on the selected treatment, you can predict how the patient will react to this treatment. And based on this prediction, you can rank different alternatives and select the best option for the patient. Adaptive learning, especially important for these surgery robots, because based on the previous operations, on the previous history of medical procedures, the system can learn. It can learn to avoid mistakes, to correct mistakes, to achieve higher precision and accuracy. And assisted decision making by performing data processing, data analysis, to provide guidance, to provide some recommendations for the doctors how to proceed with treatment. One thing to mention is the ethical considerations. So would you trust the robot to do some medical operation on your body? How do you think?
Depending on number 4, who is responsible? If
Yeah,
I know
yeah.
that many people are responsible for this process, I would trust more. But if I don't know who's going to be responsible, I mean, in previous cases, nobody, not even the director of the hospital, was responsible, I wouldn't put my money into that.
Yeah, very important thing, because if you know that the person done something, you can know that the person is responsible. Who is responsible here? The designer of a robot, the programmer, the manufacturer, or the hospital who runs this robot. So there was one case in 2015 when Da Vinci surgical system did the operation on the heart, and the patient has died. Because during operation, it did some cuts which led to the death of this patient. And there was a trial, a legal process, to find responsible people. And basically, the decision was that although all parties share responsibility, in this case, the guilty part was the hospital, which did not provide enough training for the medical doctors to use this system. Okay, about future of medical robots, how this field would proceed in the future. It was already mentioned by my colleague, nanorobots. So very tiny, very small robots which can be injected in the blood of your bloodstream, and then this robot goes directly to some specific part of your body where the disease is, for example, cancer, tumor, or some other part of the disease, and then it can do something like, for example, I don't know, shoot with lasers the disease and cure the person, or deliver some medication directly to this disease part. So many technical challenges to implement this. You need very biocompatible materials to operate inside the human body, the communication capabilities to support the retrieval of data, and many other things to solve until it becomes the reality. Another thing also mentioned was BCI, so brain-computer interfaces. Everybody talks now about Neuralink. As far as I know, we only managed to do it successfully with the pigs, but with humans it's more difficult. Why it's more difficult? Because first of all, it's difficult to get to the signal. Brain signals are very weak. So the best option is to drill through your skull and place sensors directly on the surface of the brain. Then you can get clean signal. Then you can use this signal to control some other devices, to communicate, for example, or to do, for example, restoring motor functions, or allowing to administer some treatment in case of epileptic seizures, for example. But not many people would agree to this kind of procedure. So if you apply this kind of hat with multiple sensors, there are many things which do not allow to use it effectively. First of all, here, okay, you need to remove it because they do not allow sensors to stick to the skin. After you remove your hair, you still need to apply some wet liquid, which improve the connection and reduce noise. And then you maybe get some decent signal, which with decent accuracy, about 50%, will allow you to control the computer or to write some words on the computer screen. So it's still a lot of work to be done in this area. Okay. And the final thing which I wanted to mention is metaverse. Also very popular term which is used today. Basically, the combination of virtual reality, artificial augmented reality, and artificial intelligence, so that you can put the digital twin of the patient, the robot, and the doctor into some kind of artificial world, artificial environment. And in this environment, for example, it can be used for virtual medical training, to practice on virtual patients, or you can perform surgeries in distant locations, so you can perform rehabilitation and therapy. So this kind of integration is very interesting area of research. So I had a few slides more. One more slide is about future fully autonomous medical robots. So in case of conflicts, in case of disasters, you need robots to provide some medical service. Why? Because maybe human doctors cannot go there. It's too dangerous. They can be killed. There are no roads. There are no communication. So you send the robot, you drop it from the airplane. Robot goes to find the patient, and then it can take some measurement about condition. For example, this robot developed by Sheffield University can take blood samples and find the condition of the robot. So I must complete this presentation because we are out of time, and we can discuss if you have questions.
Are there any questions? Yeah, can I take it?
I'm sorry. I mean, I basically studied medicine by watching all seasons of Grey's Anatomy, so I'm not fluent in medicine. And there's A, what I do, and B, what I do with my free time is listening and watching true crime stuff. So my main question is, if we follow through with the whole optimization of patient care, like if we enter a hospital and we speak to a little robot that will take our blood pressure, that will take our family history, that will take everything else. And then we went into surgery because we came in with a broken arm, as an example. How do we still conduct or deduct if there's a case of Munchausen by proxy, or if there is a case of abuse happening, and that is the main reason because why my arm is broken. So if we follow through with the idea that we'll take over patient care by robots and allow nurses more free time, how do we conduct those cases that for sure are happening right now and will happen in the future as well?
Yeah, despite any technological advances, it will not happen that robots will replace humans. Robots will never replace humans. Robots will never replace all jobs at the hospital. They will just replace one kind of a job with some kind of another job. So if you free the nurses from just running in the corridors and carrying some things, you can repurpose to some other medical services, like providing psychological assistance or providing more personal care on the person. So robots are not the solution to all problems. They just allow to improve certain aspects of healthcare. They contribute to improving the precision of medical services, surgeries, but still humans in the hospitals are not replaceable.
Any other question? I have a question. You have a question.
About using the artificial intelligence in medical robots. You know, when I use Bing AI, sometimes when I ask it to do something, it replies to me, sorry, but I won't. Just don't feel like it. And if it happens in the surgery room, it won't be funny at all. So how do we ensure that the AI mechanism won't do something reckless in the surgery room, especially taking into account that we can't always predict what will be the output of the AI.
Okay, so that was in one of my slides which I left out. So basically, if you consider different levels of autonomy of robots from just a simple tool, fully controlled by a human, to a fully autonomous robot, which can do everything by itself. So in the medical field, fully autonomous robots are not desired. So there always should be some kind of supervision or oversight for legal purposes, but not only for legal purposes. Just because we cannot trust fully artificial intelligence yet or ever, because in case of some critical case, there always should be a human doctor which could take over and complete this medical procedure.
Thank you. Any more ideas for questions? If not, I want to thank you. Yeah, you have a question.
So please imagine the future. I think that the future of your daughter or sons will be never that currently yours. That's, for instance, mine. I study in this building physics, and my computer was big like this room, and I use special card with open for giving the information for the robot, for the computer, the calculation for performing it as my task as a student. That when you look for me, that I look similar to you, older, but the same hand, the same leg, and one head only in mind. But the history of mine is never than you, and also the experience. Your daughter and sons in near future, after 40, 20, 50 years, will live with co-AI and co-robots. That each of person will have own robot and own artificial intelligence. This system will grow with you, will collect the same experience that you. That will be your memory and also your practice to use. Please use the same, for instance, presentation like me. That it will be possible, for instance, giving the same presentation with the same voice etc., etc., in different country, in the same time, in different university, with the same activity and the same experience like me. Also, all the activity in my home will be performed by the robots. It will be also your car for moving, etc., etc., etc. That will change the structure for performing different tasks. That will be really interesting subject how to use it and how to grow with support using electronics, software, and mechanics connected with these robots. Also, if you have any problem with the health, because we talk about medical robots, that all the communication, if the hospital and service will be performed by your own AI, your own robots. That all this information important about you will be collected and transferred with special language also to the computers, to the equipments in your hospital. It will never like Internet of Things. Yeah? That you have your twins and give all the information, and of course I have the body, I have the heart and naval tissue and any problem, but all the information about me will be collected with this supported and collected and living with us things. If you will be the mountain on the seaside, if you the sail, etc., etc., you have also all this information everywhere, because it is the cloud. That is really, really interesting history. I don't know what will be the number of human, of the people. Maybe it will stop, for instance, for 5 billion, not more, because of many problems, because our energy, our food, etc., will be not easy to perform by the Earth. You know, the problem with the climate and the place for life. But currently, it is the really evolution of the human, next step of evolution. Next step of evolution, because we create something important for us. That please believe that all these things that we talk about, the robots, the artificial intelligence, it's created by us. It is for us, not against. It is for us that we create the law, create the regulation, create the software, etc., for using it only for support us. I hope that the war will be stopped, because, you know, that is not a payoff. Thank you.
Speakers, so there was 2 presentations full of information, you know, my brain almost exploded. And I was imagining myself that I'm lying somewhere and some medical robots, you know, treating me, you know, with this mechanical arm, you know. I was seeing the scenes from Matrix movie, you know. I don't know if I like it, if I'm afraid of it. Nevertheless, once again, many thanks for our speakers for performing these 2 presentations. Thank you very much for your attention, and see you soon. Thank you.